Folks, Jayland Bio here. Today we are going to dive into solutions. I'm not talking about answers to a problem, although I'm sure I will be asking a lot of them in this unit. No, we're going to be looking at how certain things dissolve in water. We're going to be looking at properties of solutions and how different chemicals, when they are dissolved, result in different properties of solutions themselves. So let's go ahead and dive on in. Excuse me. Today, hopefully you will be able to understand how solutions are created and made and also be able to explain the contents of a variety of different solutions. So for this particular unit, we have quite a few vocabulary terms that we are going to dive into. No pun intended, because we're in the solutions unit. We're going to be talking about solute, solution, solvent, soluble. All those words sound very familiar, but do have different meanings. We'll talk about suspensions, colloids, electrolytes, and non-electrolytes. So basically a solution is a mixture of two or more substances that are uniformly dissolved or distributed throughout a single phase. So for example, if I take sugar and I take a spoonful of sugar and I place it in water and stir it up, it will dissolve. That makes that a solution. You really can't discern between the sugar and the water. The sugar molecules have completely dissolved. Now, when a chemical is soluble, it is able to be dissolved. Some chemicals are what are known as insoluble, meaning that they cannot be dissolved when they are placed in solution. The dissolving medium is the solvent. So in this case, in this example, we're looking at water as the solvent. That's what we're dissolving in. What is being dissolved is the solute. That is what you're dissolving. So you dissolve the solute, and the solvent is what you dissolve in. Get it? Makes perfect sense. So for this example, the solute is the sugar and the solvent is the water, and our solution is, well, sugar water. Now, depending on how the particles, depending on the size of the particles and depending on how the particles separate out, we have different types of solutions. If the particles will settle out of the solution because they are too large, that is known as a suspension. So if you think you get mud, eventually the dirt molecules are so heavy that they will eventually settle out of solution. Now, in between solutions and suspensions, there are things that are colloids. Colloids are things like milk and paint. So they are solutions in and of themselves because they have materials that are dissolved in water. But as you dissolve them, you cannot see the particles. You can't see the individual particles that are in the solution, but the solution is not clear. The example is things like milk and paint. So when we're looking at the size of the molecules, solutions would have the smallest molecules that completely dissolve. Colloids would have somewhat larger molecules that make it difficult to see through the solution. And then suspension molecules are so large that eventually they will separate out. Now, keep in mind, this is different between something like oil and water. Oil and water just simply has to do with the polarity of the substances. Oil is nonpolar and water, of course, is polar, so they will not mix. So certain solutions can conduct electricity when we place them into water. Those are known as electrolytes. You've probably heard that term when we've talked about things like Gatorade and Powerade, that they're full of electrolytes. And electrolytes are important for the body. They're used to replenish chemicals inside of your body that are necessary for sodium potassium pumps and keep you hydrated and things like that. So when we dissolve a solution and it forms ions, typically things that are ionically bonded, ionic compounds. Let's make that the word of the video, ionic compounds. Word of the video, ionic compounds. They form ions. Those ions have the ability to conduct electricity. And those that cannot are known as non-electrolytes. Those are things that are maybe covalently bonded that are put into water. They will not conduct electricity very well. And those are known as non-electrolytes. So when we put a solute into a solution or a solute into a solvent, there's only so much that can dissolve per given amount of solution. Think about Kool-Aid. And most people like their Kool-Aid really, really, really sweet. So they take a lot of sugar and they dump a bunch of sugar in it and they stir it up. And what they get is they get a bunch of sugar that's down at the bottom. In that instance, the solution has been saturated. When you put too much sugar in the Kool-Aid, the sugar appears at the bottom. That's because there's not enough water, there's not enough solvent to completely dissolve the solute that's there. Now, if we're before that point, that is known as unsaturated. It's less than the saturation point. When we get at that, that's known as the saturation point, and we can actually get beyond that by altering several other factors such as heat and pressure, and that creates what's known as a supersaturated solution. I'm going to try to do a demonstration of this a little bit later on, but keep in mind that there's only so much solute that can dissolve in a given amount of solvent, okay? And there's only so much that you can put in that solution. before no more solute can actually dissolve. You'd have to add more solvent or alter the temperature and pressure to get more of the solute to dissolve in solution. Now keep in mind that some materials can dissolve and some materials cannot. The term miscible refers to the ability to be dissolved into solution. Immiscible means it cannot be dissolved. So some things that are immiscible would be like water and oil, like we talked about earlier. Their chemicals have two different polarities. Oil is very nonpolar, water is very polar, and so as a result, they will not dissolve and form one solution. Things that are miscible, like salt and water and other liquids that are similar to water, will dissolve. The key thing to remember here is that like dissolves like. Things that are polar will dissolve things that are polar, and things that are nonpolar will dissolve things that are nonpolar. So lots of different things that impact solutions, suspensions, and colloids, and electrolytes conduct electricity. Non-electrolytes do not. There's a lot of different factors that go into this, but I want to make sure you have a good background on solutions before we start discussing some of the mathematical concepts directly related to solutions and whatnot. So just keep that in mind. Hope you get the learning targets for today. We've got a few more videos left for this particular unit. Guys, I hope you have a great day. We will talk to you later. Bye-bye.